breaking up into several different teams that did some amazing stuff. So I want to run through this really quick. So what we built is a theoretical terrestrial prototype of an asteroid mapper that we would build into a CubeSat. The slides that are going by really quickly because we want to get to the demo are showing some of the work that was done. We had a couple people who built custom avionics. We had people dedicated to writing the mathematics necessary to do this. We had people building Arduino sensors. That was a three-dimensional exported map that you could take and print an STL file using shapeways so that young people can get physical asteroids printed in their living rooms when we send one out to the I'm not in sync, don't pay attention to that. So what I would like to do is show you guys how this thing works. On that display is a real-time three-dimensional map that's being built by the ultrasonic sensor that is pinging out from that craft. It is going to operate autonomously. It is in your best interest to assume a defensive posture. I will say that. So let's give it a shot. Okay. Oh, great.
You guys are brave.
Yeah. Oh, man. Yeah, I'll protect the judges. If it doesn't work, I get points for bravery. There we go. All right. Watch on the screen. And forward flight.
I'm an asteroid.
Yeah, so now we're going forward, and you can see that it's mapping what you see on the screen. And so that's the demo. Yep. So there we go. And that's autonomous. Somebody wrote avionics software for that thing. It's crazy. I would like to show what a high resolution sensor is because ultrasonic is low resolution. So if you can look there, you can see these guys have a Connect. That's a better example of something that would actually work in space. So you can see they're building a three-dimensional point cloud. This gentleman over here is going to show you how we can control this thing with a leap motion sensor. So we have so much science and so much code and so much engineering going into this thing, and it's a collaboration of a lot of different teams, and this is exactly what this kind of thing is about. And maybe, perhaps, not. I'm tired. It's awesome. That's okay. We were ambitious in trying to get all this stuff in, but I think we got the point across. Please don't cut me in the back of my green. There you go. Sorry.
And this is the most dangerous part.
Yeah.
You meant for it to do that, right?
Yeah, he created there's a gesture where he flips his hand like this. The thing accelerates one set of rotors, decelerates another set of rotors, and spins itself in a barrel roll. So, yeah.
How much did you have coming into the weekend versus?
None of this. I owned a Parrot drone and a big giant bag of parts, and these guys didn't know Node.js and had never flown a copter before. They hacked that thing, got into the onboard computer, rewrote the avionics, so that did not exist 48 hours ago. Yeah.
Can we see the map?
Yeah, well, you can't, yeah, you can, so I'll show you the map here. He's just going to walk it and show you how it's doing the real-time mapping. Yeah. So as you can see, as he's walking, it's building a three-dimensional point cloud. It's not terribly high resolution because the processor on board that Arduino is not super powerful, but you can see as he approaches objects, the point cloud gets closer and closer to you.
Oh, there.
Yeah, you see now that was a really close object that he just got. So we use an ultrasonic sensor, which obviously won't work in space because there's no air for sound waves to travel through, but it's very easy to program, so we used it here.
But in a space version, you would use something like a Kinect camera with a point cloud. You would use lasers that those two physicists happened to have in their lab and offered to let us use, but we couldn't figure out how to fit a power supply onto a quadricopter. And so this turned out to be like one of the most exciting weekends of coding I have ever had, and it was because of my incredibly brilliant team. And so I can't thank these guys enough for the work that they did. I did not think this was possible when we started.
So last question, what's next? How do you take that? What do you want that to be?
What's next is a couple things. One, the avionics that were written for that would be applicable in a real cube satellite if you did something like use an electrostatic propulsion unit to change the orientation of this thing in space. The other cool thing we could do is take the center out of that thing, make a three-dimensional gimbal, put an actual CubeSat in there, and detect the amount of propulsion that's coming out of the CubeSat so that we could make a CubeSat that would behave the way it would in space. And you can think about the number of science experiments that can't be properly tested terrestrially because we don't have microgravity, or at least we can't sustain microgravity for a very long time here. Using something like a quadricopter would allow us to simulate microgravity and perform these tests terrestrially, and the incredible amount of science that could then be done because of the things that you're able to test here on Earth would expand exponentially. So, there it is. Yeah.